of this thing, threshold. Let us consider a case of a system, our hearing system. What is the threshold of our hearing system? Can anybody answer?
20 hertz.
20 to 20,000.
Very good. Threshold is equal to 20 hertz. This is threshold value. But can you answer what is the resolution of our hearing system? It is very difficult. It differs from human to human. मेरे कान अच्छे हैं, जरूरी नहीं है कि सबके वैसे ही हो. अच्छे means how much smallest value I can sense or I can hear throughout the range. What is the range of hearing? What is the range of hearing? This is threshold. How about range of hearing?
28 hertz to 20,000 hertz.
Very good. 20 to 20 kilohertz.
20,000.
Yeah. What about resolution?
Decibel.
Sorry. This is okay, na?
Yes.
Yeah. Can anybody answer what is the general resolution of our hearing? It's very difficult. Resolution of human hearing. It's very difficult to answer, right? It's very difficult to answer.
Yes.
May determine difference in the human sound in the range 1 hertz. So मैं बोलूँगा one resolution is 1 hertz. Some other person have resolution of 2 hertz. Some other may have 5 hertz. Some may have some other hertz. So like that, different human have different resolution of hearing. Hope this topic is clear to everybody.
Yes, sir.
Have you taken this into your notebook, or will you will take it later?
One minute, sir.
No doubt.
Completed, sir.
Yeah, write a problem. A PMMC voltmeter, has a uniform scale, with 100 division, has uniform scale with 100 division. Comma and continue. The FSD, in bracket write down full scale division. The FSD, full scale division, is 200 volts. Is 200 volts. The FSD is 200 volts. And 1 by 10th and 1 by 10th of scale division, 1 by 10th of scale division can be determined with fair degree of uncertainty. 1/10 of scale division can be determined with fair degree of uncertainty. Determine, full stop and continue. Determine the resolution of voltmeter. Determine the resolution of
Sir,
voltmeter.
with fair degree of
Uncertainty. No. With fair degree of certainty you must write, not uncertainty. With fair degree of certainty. I'm sorry. Please correct like this. With fair degree of uncertainty. 1/10 of scale division can be determined or estimated with fair degree of certainty. Full stop. Determine the resolution of voltmeter. Determine the resolution of voltmeter. Simple problem. What is given over here is, it is mentioned that how many divisions? 100 divisions. What is the instrument which is doing the measurement? It is
Voltmeter.
voltmeter.
Yeah. So 100 division is corresponding to 200 volts. So one division will be how much?
2 volts.
Very nice. One division will be equal to 2 volt. So just now I told you what is the resolution? The smallest mark in the instrument or the smallest measurable input. So how much smallest value we can determine? 1/10 of division, right? 1/10 of division. So one division is 2 volt. 1/10 of division will be how much? 1/10 of 2 volts, right? That will be equal to how much?
0.2.
0.2 volts. So this is the resolution. If we understand the definition, we can very easily solve the problem. It mentioned that there are 100 divisions and the maximum value mark is 200 volts, like this. Instrument is like this. There are 100 divisions. The maximum mark is 200 volts. And it is also mentioned that this 100 division, okay, the instrument is able to measure 1/10 of division. So the ability of instrument which can determine the smallest value is called as resolution. So one division is making 2 volts measurement, 1/10 of division will be making 0.2 volts measurement. That is the resolution of that instrument. Hope it is clear to everybody.
Yes, sir.
Yeah. Let us quickly go to next topic which is mentioned. What is that? Range and span. Are you ready for that?
Yes, sir.
Range and span. So let us see this page which is covering the difference between range and span. Let us suppose that we have an instrument which is doing spectrum measurement. Have you worked on CRO, cathode ray oscilloscope? CRO.
Yes, sir.
Yeah. This is just similar to CRO, except that here x-axis is frequency. Is it clear to all?
Yes, sir.
Yeah. The instrument in which x-axis is frequency is called as spectrometer. Okay, I'm not going into that because that is not the topic to be discussed. I just want to explain you what is the difference between span and the range. It's very simple. You can understand from this example. Suppose we have a spectrometer whose range is 3.7 gigahertz to 4.2 gigahertz. Then its range is how much? 3.7 gigahertz to 4.2 gigahertz. So start value is 3.7 gigahertz and last value is 4.2 gigahertz. Is it clear?
Yes, sir.
Yeah. What about span? The meaning of span is take the algebraic difference between upper range value and lower range value. Here upper range value is 4.2 gigahertz and here lower range value is 3.7 gigahertz. If I subtract these two numbers, we get a number that is nothing but the span of the instrument. So you see 4200 minus 3700 will be equal to some 500, that is nothing but because it is actually converted from gigahertz to megahertz. Okay, then we are getting span value as 500 megahertz. Is it clear to everybody?
Yes, sir.
Yes. Let us write down the definition of range and span. The range of instrument is specified by lower limit and upper limit, in which it is designed to operate, to measure, to indicate, or to record the measured value or variable. And what about span? The algebraic difference between upper range and lower range value is termed as span of the instrument. Hope it is clear to everybody. Yes, no?
Yes, sir. Clear.
Example. Spectrometer, which measure the signal in the range 3.7 gigahertz to 4.7 gigahertz as, can I write over here? Can I write over here?
Yes, sir.
Has range is equal to 3.7 gigahertz as start value, 4.7 gigahertz as stop value. And span of this case is equal to how much? Okay, first what I am doing is converting gigahertz into megahertz. 4.7 gigahertz I am converting into megahertz minus 3700 megahertz. Algebraic difference between these two values, and that will be equal to 500 megahertz. This is the span value. Hope it is clear to everybody. Please acknowledge.
Yes, sir.
You want to note down this?
Yes, sir.
Please note down. I think taking more time.
Done, sir.
Okay. Next. What is next? Linearity and hysteresis. Linearity and hysteresis. Let us first see linearity. Sometime in order to measure linearity, we measure non-linearity. So whatever term asked, you please give same answer. Okay, you might get confused. Forget it. Later I will tell you what to do if non-linearity is asked, right? Okay, in order to see what is the meaning of linearity, let us see the same curve, input versus output curve of an instrument. Ideally, suppose we are getting a relation like this. Ideal case. Right? Yes, no.
Yes, sir.
Yeah. Let us suppose that actual value is something different. Actual value is something different. This is actual curve. Actual curve is slightly deviating from the ideal curve. Are you able to see this thing? Okay. You see, actual value is slightly deviating from ideal curve. Okay. At which place you are observing maximum deviation? Is it at this place? Yes,
Yes,
no?
sir.
Okay. Find out this peak. Let us represent this with P. Okay. Then the percentage of non-linearity is equal to the P value divided by, this is suppose FSD. Already I told you what is FSD. What is FSD? Full scale deviation. Write down FSD over here. Multiply this with 100. You will get percentage of non-linearity. Hope it is clear to everybody. If it is clear, please note down this. And write a word about it. Are you ready to write?
Yes, sir.
Just a second, huh? Okay, continue, please. Write down. Now, whatever ask, linearity of instrument ask or non-linearity of instrument ask, please write down the same definition, right? Is it clear?
Yes, sir.
It is defined as the percentage of, it is defined as the percentage of maximum deviation, percentage of maximum deviation of any of the calibrated value, any of the calibrated value from the ideal straight line, from the ideal straight line
Sir, any of the calibrated?
value, calibrated value
Calibrated value. Next
from
one is
the ideal straight line. Are you getting a question why I am giving the word calibrated value? If genuinely it is coming, ask me. I will give explanation.
Yes, sir.
Yeah. अच्छा, first complete the definition. क्या लिखे आप लोग?
It is defined as the percentage of maximum deviation of any of the calibrated value from the ideal straight line.
Right, that's it. The definition is over. This is mathematical representation. Note down this thing, then I will give you the explanation for that word. Can I give?
Yes, sir.
Before starting, you may see that in your transducer lab. Before starting any measurement from instrument, what we will do is we perform several times calibration. Already I have explained you the meaning of calibration. Calibration is done several times before measurement. कभी आप लोग देखे ग्रोसरी शॉप वाला क्या करता, अपने weighing scale को make it off, make it on, set the value, set the zero. You will do that work at the starting. If you have observed that thing, maybe you can answer. Anyhow, in our laboratory or in any industry, before starting any measurement with the instrument, several times we check the instrument. The checking of the instrument before actual measurement is called as calibration. Is it clear to everybody?
Yes, sir.
Checking in the sense correcting, right, sir?
Yeah. पहले क्या करते मालूम है? Now you are asking next question. It's very nice. Next question. How we will do calibration typically? What we will do is we have. I will take the help of next screen. Example I am taking. Example of calibration done in laboratory, right? So let us suppose that temperature instrument, that is called as, I'm saying, taking the case of simple. Okay, maybe you are aware of thermometer. Are you aware of thermometer?
The clinical or digital?
Yeah, clinical.
Okay.
Yes,
We are aware.
Take both clinical, analog, as well as digital. Okay, both. Displaying some number. In this, some water is available, and we are actually heating this. What we will do is, we observe, suppose this is the ideal instrument, and this is under calibration instrument. What we will do is, we apply heat and check the value given by this thing, and try to compare this with this value. Suppose this is reading at the starting, say temperature is suppose 20 degree. This is giving start temperature. This is showing 20 degree, and this is showing say 22 degree. What we will do is, we will continue heating and go up to the last value. Last value under measurement. Suppose that is looking to be some 100 degree. So this instrument is showing 100 degree and this instrument is showing 110 degree. 110 degree. So what we will do is we continue this process. This is called as iteration 1. This is called as what? Iteration 1. Similarly, we go for iteration 2 and we go for iteration 3 and so on up to n iteration. N iteration. So that we get satisfaction that both instruments are giving same starting value and same ending value. Hope it is clear to everybody.
Yes, sir.
Yeah. Usually in laboratory we do calibration once or twice. After that we mentioned that the instrument under measurement is having this much amount of error. Consider that error and that add that error at last. After measurement, add this much error. Suppose you see how much error this instrument is showing. 22 minus 2, 20 is equal to 2. So plus 2 degree error is showing by this particular instrument. And final value 110 minus 100, that is plus 10 degree. So that much error we can add at the last. That is different story. But the procedure for doing calibration is this one. We measure the start value, we measure the end value of both ideal instrument. Okay, this measurement is done with both ideal instrument as well as instrument under test. After that only we do starting of measurement on that particular instrument exclusively. Hope it is clear to everybody.
Yes, sir.
Now, I am moving to next topic. Okay, the same topic only, the second part. And that is nothing but hysteresis. Have you heard the word hysteresis? Maybe you have seen this in your engineering physics. Just check yourself whether you have seen or not.
Yes, sir, I heard, but where I don't know.
Okay, no problem. Let me show you that. What is the meaning of hysteresis?
The hysteresis graph shows the paramagnetic and ferromagnetic.
Correct. So I will write the first thing I will write about hysteresis. Who is responsible for hysteresis? Can I write magnetic element
Yes, sir.
is responsible for hysteresis effect?
Yes, sir.
Remember this. Is responsible for hysteresis effect. But what is hysteresis? We will see that. Right? So to see what is hysteresis, again I need to draw the same curve. We have a curve which shows the relation between input and output. Suppose this is our ideal curve. When we try to take the reading in increasing order, increasing order. Suppose we are getting like this relation. And suppose when we try to take the reading in decreasing order, this is starting value, this is FSD, right? So starting from 0 and moving to the final FSD, I'm getting relation like this. Increasing order. And how about this? Practical reading in decreasing order. You see, two things we need to observe over here. One is the instrument is not overlapping with the ideal value. So it is having nonlinear problem. Above nonlinear problem, you see, when we increase the value in increasing order of input, that is 0 to FSD, I am getting a relation like this. If I observe the output value in reverse order, instead of 0 to FSD, I'm applying the order from FSD to 0. I'm getting like this type of response. If this type of response is observed, then we say that the instrument is affected from hysteresis effect. Hope it is clear to everybody.
Yes, sir.
Write down a word about what is hysteresis. Right. Are you ready to write? Should I dictate?
Yes.
Right. When a device is used for measurement of any parameter, when a device is used for measurement of any parameter, comma, first for increasing value of measurement, and then for decreasing values of measurement, comma, and continue. Then usually the two output readings differ from each other. Usually the two output readings differ from each other due to hysteresis problem. You can support this statement with this term. And also you must write who is responsible for hysteresis effect in the instrument. Who is responsible?
Magnetic element.
So this much is enough for today's class. Please give your attendance. Well, answer your attendance.
1, 2, 3, 4, 5 present, sir.
1 second. One, two, three, four, 5. Okay, continue please. Only this much?
Roll number 13. 1 3.
Sir, 10 present, sir.
Okay, 10, 13. Please continue.
Sir, 16.
16,
Sir, 22.
22,
29.
29,
35.
35,
Sir, 32.
32.
36.
Please loud and clear.
36.
36,
39.
39,
28.
28. Continue please up to last. Finish.
48, sir.
48,
50, sir.
50,
51.
51, continue please.
307, sir.
307. 307 you said?
301, sir.
301. Then
307.
301, sir.
okay,
303, sir.
301 taken, 307 taken, 303 also taken. आगे बढ़ो बाबा. हो गया?
Yes.
Okay, thank you.
मी अटेंडन्सला रा. अटेंडन्सला रा. 1000. मैंने निकला